Hi, welcome to Bits and Proofs. Imagine you want to build an AI assistant that answers questions from your own documents, your company knowledge base, your code base, your product manuals. The technique that makes this possible is called RAG, and RAG is built on one key idea, embeddings. That is what this video is about. Here is the full picture. You take your documents, run them through an embedding model, and each document becomes a list of numbers. You store those numbers in a vector database. When a user asks a question, you embed the question to find the closest numbers in the database and hand the matching text to the model. That whole chain is called RAG. Today we learn step 1. Once you understand embeddings, vector databases and RAG follow naturally. This is the foundation everything else sits on. Here is the core problem your system needs to solve. A user asks your assistant, "How do I reset my password?" The help page that actually answers it is titled Account Recovery Steps. Look closely, not one word is shared between them. So a plain keyword search finds nothing. Your AI needs to match meaning, not just words. That is exactly what embeddings make possible. So what is an embedding? An embedding is a list of numbers that captures the meaning of a piece of text. Here is the embedding for account recovery steps. It is simply a row of numbers. Just numbers, usually a few hundred to a few thousand of them, one long list for each piece of text. Here is the key idea. Think of each list of numbers as a position in space. Text with a similar meaning lands in a similar place. Close together means similar meaning. Far apart means different meaning. We will picture this in 2 dimensions, but remember, a real embedding has hundreds of them. Look at this small map. The animal words cat, kitten, and dog sit together in one corner. The vehicle words car, truck, and van sit together in another. And here is the surprising part. The model was never told these groups. It learned them on its own from the way the words are used in real text. So how do you actually get an embedding? You send your text to an embedding model and it hands back the list of numbers. In code, it is almost this simple. You call embed on your text and you get back a vector of a few hundred numbers. 2 quick points. The model does all the work. You never design the numbers yourself. And it is cheap and fast. Embedding a sentence costs only a tiny fraction of what it costs to generate one. Now, how do we measure a similar meaning? Picture each embedding as an arrow from the center. Reset password and account recovery point almost the same way. Pizza recipe points off in another direction. We measure the angle between 2 embeddings. A small angle means similar meaning. This score has a name. It is called cosine similarity. Let us put it together and watch the search succeed. Your question, how do I reset my password? The best match by meaning, account recovery steps with a similarity score of 0.91. Here is the whole method. Embed the question, compare it to every document, and return the closest one. No shared words needed. This is called semantic search. Once you can measure meaning, a lot becomes possible. Semantic search finds documents by meaning even with no words in common. Recommendations suggest items that sit near the ones a person already likes. Grouping and cleanup. Cluster similar text together or find near duplicates. And giving an AI the right context. Fetch the passages most relevant to a question, then hand them to the model. One more thing worth knowing. The same idea works for images, audio, and more. Each one becomes a list of numbers in the same kind of space. That is how you can search photos with a sentence. The words and the picture land close together when they mean the same thing. A few tips for using embeddings well. First, use one model for everything. Only compare embeddings that came from the same model because each model builds its own space. Second, split long text into chunks. Embed a paragraph at a time so each piece has one clear meaning. Third, store them once. Embed your documents ahead of time and then only embed each new question as it arrives. Let us bring it together. Remember three things. 1. An embedding turns text into a list of numbers that captures its meaning. 2. Similar meaning lands close together, so closeness measures similarity. 3. This is what makes semantic search work, matching by meaning instead of by words. So where does this go next? Now that you understand embeddings, the next question is how to store millions of them and find the closest ones in an instant. That is the job of a vector database, the next video in this series. And once you have a vector database, you have everything you need to build RAG, an AI that truly knows your data. Thanks for watching. If this helped, do subscribe. More AI engineering content is coming soon. And while you are here, check out the other AI engineering videos already on the channel. See you in the next one.